So exercise related to nuclear decay and the binding energy. The questions. Question 31 we will do. In one type, and now this is a question about the fusion reactor as compared to only talking about a nuclear fusion. So as you can see, this is a this is a fission reactor. One type of a fission reactor that the coolant is a liquid metal alloy of a sodium and potassium. The sodium absorbs neutron from a reactor core and become the isotope of sodium 24. And sodium 24 emit both beta and gamma radiation. So you can see control rod, a liquid metal, a shielding is there, a core is there, and a heat exchange. State what is meant by a nuclear fission and explain why energy is released during a nuclear fission of a nucleus such as uranium. So first, why the energy is released and what is the meaning of the term nuclear fission? Nuclear fission means when a heavy nucleus break down into a lighter, or in a nuclear fission, it's a splitting of a large nucleus into smaller nuclei. And what will happen? The binding, and when it will form a fragment, the binding energy per nucleon increases because the binding energy per nucleon for the original reactant or the nucleus which undergo fission and the fragments which are produced. So what will happen to the binding energy? The binding energy per nucleon, when we compare them, this will have low binding energy per nucleon and this will have high binding energy per nucleon. So when the nuclear fission happen, the fission fragments will have high binding energy per nucleon. So when the binding energy per nucleon increases, the reaction is always exothermic, or it releases energy. You can relate by this, or you can also relate the change in the mass, because what will happen whenever the total overall mass decreases, the mass converted into energy, and that is why the energy is released to the surrounding. The next is a sample from a coolant from the reactor contained 1.23 exponent 13 nuclei of the sodium 24. Calculate the activity of this sample when it is first removed from a reactor. The decay constant, or a lambda, is given to us, which is 1.3. So we have the formula that the activity is equals to minus lambda n. This negative sign only indicate that the activity always decreases. So we have the lambda, the decay constant is already given to us, and we also have so for a calculation point of view, you can ignore this negative sign. The formula always include a negative sign, but for calculation, we can ignore. So the decay constant, which is 1.3 into 10 to the power minus 5, second inverse, multiply by the half-life, multiply by the number of the nuclei which are present. That is 1.2 into 10 to the power 13. So 1.2 exponent 13, when we multiply, it will be 1.56 into 10 to the power. So 1.3 into 10 to the power minus 5, that is a decay constant, and 1.2 into 10 to the power 13. So it will be 1.56 into 10 to the power 8, second inverse will be the activity. Then the shield is placed around the core of a reactor. One physical property of this shield, this shielding must have, and name the material that is usually used. Yes, activity you can write becquerel second inverse or BQ, that's fine. So for a shielding, which material is suitable and why it is suitable? Because what is the main purpose of this for a shielding, what is the main purpose? We don't want the radiation to escape. So which material is like concrete, thick concrete can be used, or it should have a very high density. Material should have a very high density, so it will prevent the radiation from escaping from the to the surrounding. So, and the best shielding material should be concrete. So property should have a high density, and a material which we use, we'll use a concrete there. Because like lead and concrete can stop alpha, beta, and gamma, all these radiations. That's why we prefer these as a shielding. Lead and concrete both can stop, but compared to like concrete is much cheaper as compared to lead. That's why we selected a concrete here. Many governments are funding a research into replacing of fission reactors with the fusion reaction reactors. Suggest why? Like why fission reactors are like they're trying to shift to a fusion reactor. What is the reason for that? Because usually the fission fragments are radioactive. Like the waste which is produced, the fragments which are produced by a fission are radioactive, emitting out radiation. But fusion fragments are not radioactive, it are not emitting out radiation. And another thing, like the fusion fuel is a limited, like uranium is there, polonium is there. So these are limited amount of fuel is available. But as compared to the fuel for a fusion, which is hydrogen and helium, which is virtually unlimited or too much we have. So one is the waste which is produced is radioactive, and the other one is the fuel which is available for fission is a limited as compared to that of fusion. The next we have the element polonium was discovered by Marie and Pierre Curie in 1898. Fusion produces the waste, but that waste is not radioactive. Whilst they were investigating the radioactive substance pitchblende, polonium is an unstable element and decay by alpha emission. So explain the term random and spontaneous. So what is the definition of a random? We did that. Random means can't say when the next nucleus will decay, or we cannot say when a nucleus will decay, or which nucleus will decay next, that we cannot. And spontaneous means it is not influenced by external factor or cannot be influenced by external factor. Then we have a particular isotope of a polonium decay to lead. Complete the nuclear equation for representing when a when it's an alpha decay, the nucleon number decreases by 4. So this should be 210, and a proton number decreases by 2. So this should be 86. This we just have to complete a equation. Then in this decay, the alpha particle is emitted with a kinetic energy. So alpha particle has this kinetic energy. Show that the speed of alpha particle is about this, and alpha particle has a mass. So it's a straightforward question in which a kinetic energy is equals to half mv square. In the previous one, no, this should be 82. By mistake, I wrote 86 there. This should be 82, 2, and 210. The nucleon number decreases by 4 and the proton number decreases by 2. This should be the case. So we have a kinetic energy is half mv square. So kinetic energy is 8.5 into 10 to the power minus 13. it will be half. M is the mass of alpha particle, which is 6.64 into 10 to the power minus 27. And the speed of a, so we just have to simplify and get the speed, and we'll get about 2.7 2 exponent 7 meters per second. This is the total mass of the alpha particle. No, they give the total mass of the alpha particle. They did not give us the mass of nucleon. If the question was like instead of it was given mass of a nucleon like a proton or a neutron, then I will multiply by 4. But this total is already given, so I don't have to multiply by 4. This is the total mass given. The next is the diagram shows a product of this decay. Explain why the lead nucleus recoils during a decay. Like why the lead has to move in opposite direction as alpha. Remember, momentum is conserved. If the momentum before is 0, the momentum after should also be 0. So if one fragment is moving towards the right, the other fragment must move towards left. So explain why the lead nucleus recoiled during a decay. So the answer is the momentum must be conserved. Initial momentum is 0, so the final momentum should also be 0. So, so the momentum of the alpha particle should be same as the momentum of the lead, but in opposite direction. So the structure should be momentum is conserved, one thing, and then they should have equal and opposite momentum so that the final momentum is also 0. Calculate the speed at which the lead nucleus begin to recoil. So initial momentum is 0. If I apply the conservation of the momentum, lead is there, which is 82, remember. And the nucleon number will be like a mass of proton, neutron, electron are constant. So that will be given to you. So momentum before is 0 for lead, 0 for alpha is equals to momentum of lead, Pb, minus momentum of alpha. Why negative? Because if one is moving towards right, the other is moving toward left. Any one of them I can take as negative, or I can say momentum of alpha will be equals to momentum of the lead. Momentum is mass of alpha, velocity of alpha, mass of lead, and velocity of lead. If you compare, like, look, this is alpha particle has 4 times the mass like the nucleon number. And what about lead atomic number is 82? What about the mass 206? So if I see one nucleon has a mass m, so 4 nucleons, alpha particle are 4 nucleons, so the mass will be 4m. And lead, which is 206, so the if one is m, so 206m. So alpha particle, I can say 4m into speed of alpha is equals to 206m into speed of lead. M will cancel with m. So it will be 4 multiplied by speed of alpha divided by 206 is equals to speed of a lead. So it will be 4 multiplied by speed of alpha, which was 2 into 10 to the power 7 divided by 206. Yes, you can also do like U is also a right term. Like one nucleon has a mass of U. So 206 will be 206 U. So you can use the term U as well. Like you can say this will be 4U and this will be 200. And so U cancel out with U. So just have to simplify and you'll get the speed at which the lead will recoil. Is it clear? This one? Explain why most of the energy released in these decays transferred to the alpha particle. Look, if you see the energy, which form of energy it will have when it is moving. This has kinetic energy. This also has a kinetic energy. And kinetic energy is function of what? Kinetic energy is a function of mass and speed. Half mv square. The relation between kinetic energy and mass is directly proportional, but relation between kinetic energy and speed is proportional square. Because alpha particle has a lighter mass, so its speed will be much higher. And when the speed increases, like speed is double, kinetic energy will be 4 times. Where for lead, what will happen? It's massive or heavy compared to alpha particle, so particle will move slower. So it will have less speed, that's why less kinetic energy. So the question was like why most of the kinetic energy is carried by alpha particle rather than lead. So what is the reason for that? Because alpha particles are lighter and the particle will have more speed and kinetic energy is directly proportional to speed square. That's why particle carry most of the kinetic energy than the lead nuclei. Is it clear? Any doubt in this? You can also relate the momentum like Ek, the kinetic energy is P square over 2m. This is also a formula which relate the momentum, mass and kinetic energy. So you can also relate this if an object is having, if two objects have the same momentum, the one which is having a less mass will have more kinetic energy. So how to structure this answer? You will mention that the kinetic energy depends on the mass and speed. Kinetic energy is proportional to the speed square because alpha particles are lighter. So the particles carry most of the energy or the particles are moving fast. So the alpha particle carry most of the energy. So one thing you will relate that the kinetic energy depends on mass and speed square. The second point you will say alpha is having less mass, so higher speed, greater kinetic energy proportion. So whenever we need the power of the sample, power of a sample is the energy of one, like energy multiplied by activity. We'll get the power because activity is 1 over second. So question is polonium has been used as an energy resource for a thermoelectrical cell. The isotope of the polonium decay with 5 into 10 power minus 3 per day. A sample of a polonium, like this is an activity is given with a mass of 0.5 gram releases the energy at a rate of about 70 watt. The activity of a sample is 8.1 exponent 7 megabecquerel. The alpha particles are emitted out with a kinetic energy of 8.5 exponent minus 13 joule. Show that this sample releases the energy at a rate of about 70 watt. So we want to show that like the power which is coming out or the emission is there every second, that is about 70 joules per second or 70 watt. So we know the formula that the power is energy multiplied by activity. So energy is how much? It is 8.5 into 10 power minus 13. That is energy from one. Like alpha particle is emitted, this is energy. And how many are emitted out? 8.1 exponent 7 megabecquerel. So we have to convert into becquerel. So it will be 8.1 into 10 power 7. Mega means 10 power 6. So this multiply 10 power 6. So this will give us the power of the sample, which is about 6.89 watt or approximately 70 watts. Is it clear, this one? How we worked out the power of the sample? The next is this sample of a polonium would not be suitable to provide energy for a period of several years. explain why using a calculation in your answer. Like if you want this polonium for several years, this is not suitable. So what we can do from a decay constant, we already have a decay constant which was 5 exponent minus 3. We can find the half-life. So the half-life is equals to 0.693 divided by lambda. So 0.693 over lambda. Lambda is what? 5 into 10 to the power minus 3. So when you simplify, this will give us a half-life. So half-life, it will come out around 138.6 days, approximately 139 days. So 139 days is a half-life. Like after every 139 days, if you convert, because like you have a 1 year is there, which is having three on average 365 days are there. So if you take a fraction of that, like in terms of the year, if you divide, so 139 divided by 365, which is equivalent to about 0.3 or 0.38 years, or I can say zero point 0.4 years. So means zero point 0.4 years is a half life. Like after every zero point 0.4 years, the sample will become half of its original value. So as the sample will be, because if we want something to use for a longer duration of a time, then we prefer that it should have a longer half life. So the amount of the radiation will not change too much. But this sample is having a short half life compared to, we want to use for if I want to use something for several years, then I prefer a half life to be in years. But this has a half life less than a year, which is about 0.4 years. So if the half life is then less than a year, means even within 1 year the sample will become, like after zero point 0.4 years, or you can say after about 4 months example. This is just an example. Like after about 4 months, the sample will become half of its original value. And power is energy divided by activity. So if the activity will become half, the power will also become half. So it means it won't be able to provide the same 70 watt. Then the power output will reduce to 38 watt. So even within a year, the as a half-life is less than a year, so within a year, the activity decreases or reduced to half or less than half. So the power of the source will also decrease. So that's why this will not be suitable for the use for a longer duration. So how to structure this answer? 1 mark, you will refer the calculation about the half-life. Then you will link that the shorter half-life is there, means its activity will decrease to a greater value, like reduce to a smaller value after every half-life, or within a year the activity will become less than half. So means the power from the source will also be half. Is it clear? Discussion from nuclear physics. Any question or doubt related to the session?